So hello, welcome. Got a couple inquiries in the comments asking me to show how got the FPS controller set up, right? So let's go over the 3D scene here happening. I'll break it down and then we'll set one up ourselves. So here I have a node, 3D node of world. I renamed the world. I have my stage here, which contains the box, which does have a Kenny texture on it. If you're wondering, you can go to the asset lib. Um, this is the Godot Jolt physics engine, I believe. I believe it's an engine, or it just betters the current engine that Godot is already using. But you type in Kenny. Um, and Kenny prototype textures. There you go. So if you want to have the same textures, shout out to Kenny for the textures. What else? We have our head, which is another Node 3D. This contains the camera, body being the collision shape 3D, which is a capsule right here. Um, our feet. Also, you have to remember that on the rigid body 3D node here on the physics body 3D, you want to disable angular X, angular Y, and angular Z, so you can actually move your character. Keep these on, just flop around. You can see there's jumping, there's moving, and here I'm tracking if we're on the floor or we're not on the floor. Jump up, not on the floor. We drop down. It's a very basic, simple controller. Also, the environment here is where I have ID. Wherever you want to put it, up to you really. Gonna make a new folder, rigid, create it here, and now we're in our main project. So right away, we're gonna be working with 3D. What else? 3D. Rename this to world. Like we're gonna hold most of our stuff. Let's create another node 3D where we're gonna have our stage. Honestly, like any objects. Let's create a CSG box. Basically, just a cube. Gonna be like our little platform. A little smaller, thinner. I mean. So that's the y-axis, and then x and z represents its width and length. So we can go for like 15, like 15, just so it's a big field. Open up your assets lib and type in any uh NA project textures. We're gonna download it. Click install. Once this is done, we're gonna head back to our 3D. Now on the material on the CSG box, we can click new standard material 3D. Click on it again, and we want to go to albedo, apply texture, quick load for a dark one. Now if you want it to be nicely positioned like the boxes, have separate, go to UV1, and then turn on the trip planner, have box separate. Pretty cool. Okay, so we have our dark layout. Now we could create our env, is like where our world is gonna be, or the environment, or sun, whatever. So let's add sun to scene, add environment to scene, drag both of those in there. Where's the sun? Good, just anywhere. Okay, so now let's go over character, setting up our controller. So on our stage, because he's gonna be spawned in on the stage, obviously. On stage, click add node, We're gonna go for rigid body 3D. Click create. If you look over here and hover over this, it says it doesn't have a collision shape 3D. So basically, this rigid body doesn't have any shape. So we could give it a physics material as well. But just add a collision. Collision shape 3D. And you can shape it whatever. I'm gonna shape it into a capsule. It's like character probably like thing you could have. Drag them up a little. Our collision shape doesn't have to be anything. Literally just how it is. Um, Other things that we need. We can rename this into body. This is our body. Now let's add a node 3D where our camera is gonna be. Camera 3D. Rename this into head. Because really this is where our camera is. And then we can drag it up into relatively, enough where you want the head to. One last thing we need is its feet, and that will be a raycast 3D. It's quite big, so we can go transform it. Scale it by like 0.5, 0.1 even. You don't want it to be too small. In this instance, it's like very tiny. It is long enough. Want it to be not too big, not too small. Alright, but it looks like these values actually. So there you go. This is like as small as we could go. Center it right where the character is. So there you go. Now we can rename this into our feet. And there you go. This is your basic setup. This is everything you need to actually start moving this character. And well, also go into project settings, input map, and then map your favorite keys. I'm gonna map W, A, F, D, and then jump. So W is W, A is A. Yeah. And then jump's gonna be. You can actually so let's rename this into our player. It is a player. One more thing. You need to go into the player, go into its rigid body. Then in collision, I'm pretty sure it's in mirror angle. Axis lock. Yeah, we need to axis lock it and just lock angular X, Y, and Z so it doesn't flop around. You're not going to be able to move the character. So now let's add a script. Attach a script onto here called player GT, which is totally fine. Now I'm gonna drag and drop this so I have a reference. And this code is going to be up on GitHub as well as the whole project, so you can just download it and mess around with it. So we have to declare a couple of things before we can start working. Well, let's not get ahead of ourselves. Like, we're not going to go over jump velocity. Acceleration, basically this is how fast our player can accelerate, right, to what certain amount. Us pressing W, A, or S, or D, we can accelerate to. So this is a multiplier that we're going to use later on. Provide it now. Speed, speed is our character speed. So fast we're going to be going and moving around. Then max speed covers like how fast until what certain speed our character can reach. Move input covers our 2D, which is mouse input. You don't set this to 0 here, you're gonna get a very nasty error later on. So also we need another method. We're gonna be checking if we're on the floor, and when we spawn in, obviously we're gonna be on the floor. Sends describes how like our mouse sensitivity be tweakable. Stop speed, which is our character gonna stop moving. So welcome. I missed out on some things. Here I declare my camera. Basically grabbing the camera 3D, which we declared here. Our head, so we can rotate it later on. Our feet. Down the process delta. If gravity scale is less than or equals to 0, gravity scale equals 0. This is to normalize the gravity. On floor equals false, so by default, when we run this, it's gonna be false. So move input equals vector 2.0, and we declare our, oh, actually we don't. Oh yeah. Oh, this is mouse input. Move input equals vector 2.0, and this is where we actually get vector, I believe. Here we said 0 again, var there, so here is the direction we're moving in, I believe. Vector 2 move underscore input dot get vector, and here we're gonna get all of our keys. So our A key for moving left, our D key for right, our S key for moving down, and our W key for moving up. So now the direction of which we're facing will be modified. Oh, well, our direction. This is for movement. Upon input dot x multiplied by head dot global or transform basis dot x. Then we do minus equals move underscore input, and this basically handles our input, our movement. Global or transform dot basis dot z, and now our velocity is going to be lerp velocity direction multiplied by max underscore speed, max speed, and our acceleration multiplied by our acceleration multiplier, and then by our delta. And then here we apply central force, and then kind of force will apply our own velocity. If feet dot is colliding, and we basically want to say is underscore on floor equals true. So if we're colliding, that means we're touching the floor. Gravity scale, set it to 1.0, just so our gravity is normal. And our asshole multiplier can be all our print. And then we can print on the floor. Now, if input dot is underscore action just pressed, and then jump, this is where we handle our jump. And also is underscore on floor turns true or false. Asshole underscore multiplier equals 0.1 is underscore on floor equals false, basically saying that we're not on the floor because we're jumping up. And then we want to apply central impulse of vector 3 dot up times jump underscore velocity. Do we not have jump velocity declared? Jump vel. We actually never declared jump velocity. Jump. And then we can do it here. So this will be correct now. Okay. So one more thing we want to check for, if we're not not touching b dot is underscore colliding. So if it's not colliding, we want to print not touching, right? Is underscore on floor equals false, and apply central force, or actually apply central impulse. No, what am I doing? And then enable gravity scale back to 1. So if we're not colliding, our gravity needs to be 1. Because we're not gonna fall down. If we set this, if we don't set the gravity scale, I'm gonna show you what's gonna happen. So now let's handle our movement, our camera movement. It's all getting handled in the underscore process. Pretty crazy. But here we're gonna use the camera variable that we declared earlier. Now we're gonna call rotate underscore degrees. Rotation degrees dot x minus equals mouse underscore input dot y multiplied by our sense, which is our mouse sensitivity, and then by our delta, which I believe is like FPS. Camera dot rotation underscore degree. I wish I could explain this a bit more and a bit more clear. It's just I don't have that game developer knowledge. Camera dot rotation underscore degrees. So we're calling our clamp function. I believe clamp just constructs a vector. Yeah. So it returns 3 float numbers. So we're gonna clamp camera rotation degrees dot x and minus 80, and you can set this to be whatever you want. Wrong? Oh, it didn't read that comma. Okay. Or did it? Yeah, it did. Okay, and now we actually want to do head dot rotation underscore degrees dot y. Mouse underscore input dot x y by sense delta, and I'm sorry, I don't have two screens. And then here we want our mouse for input equal to vector 2 dot 0. Wow, I don't know what just happened, but this is pretty I don't know. All my shit just got like unformatted. Like, okay, this is how it's meant to be. So we get our 0 here. Mouse input 0. So now we want to integrate our stopping forces. So let's capture the actual input. Because if you load in right now, you won't be able to move your mouse. If event is input event mouse motion. So if we're moving the mouse, we want mouse underscore input to be event dot relative. So this is pretty much all of the code you're gonna need. Pretty sure we just do save and then run the current. But yeah, you're gonna have your character. So one problem you're gonna notice is that we're constantly gliding, and then can't fall off. Binding. Mouse is smooth though. We're gliding on the floor. So one way to solve this is to integrate forces, which does not use physics and just stops it artificially. I'm not gonna go through the code. I'm gonna paste it in. So again, big shout out to this guy here on Chevier. I'm sorry if I'm pronouncing your name wrong. Go ahead and sub to this. This is 1-year-old tutorial, which I stripped down the code pretty much. Just for the controller, I don't have any player or any code, so I kind of redid it in Godot 4.2 because this is a little outdated. So big shout out to this guy. Go subscribe to his channel, leave a like. I'll make sure you have done that. So fixing this, well, fixing us not dropping down. As I mentioned, I'm gonna show you how to. If we're not touching, if we're not colliding, you want to actually set the gravity scale 1. Right? Because if we don't, well then, gravity never gets scaled and we just fall through. Okay, gravity gets scaled now. One thing, CSG box, make sure you can collide with it. Here, use collision. So make sure it's collidable. You walk on. And there we go, we can jump. We're colliding. We are on the floor. If we're not touching the floor, we will drop down. So thanks everyone for watching. I'll leave a like.